Am I audible? No? Am I not audible? Am I audible? Yes, okay. I got yes. Thank you. Okay, let me continue. This session is going to be very interesting, and you would love this session because in this session we are going to see that how to train the neural network model. All right, how to make the training neural network train this thing. So you have seen this particular thing, means everything is written over here. So I just want to ask you why it is okay. All right, chalo. So let me copy it and let me 1 minute. Okay. There are several of them. I think this is the better way. So let me just remove this. So I'm going to give you a way to train a single neuron. If you have a single neuron, perceptron training rule is there for training a single neuron. If you have a one neuron, then how can you train this? Training means what? Finding out the right parameter. Okay. So let's assume the scenario is this. Let's assume that you have some positive examples over here, and there are some sorry, red se bana diya. Okay. There are some positive. So we should not. That's it. Okay. So let's assume that this is x. This is the x-axis, this is the y-axis, and let's assume that these are the positive things. These are the positive examples, and let's assume that it is linearly separable. Otherwise, what is the point? Because this is the linear classifier. If things are not linearly separable, then asking the classification from them is not justified. So let's assume that these are the points that we have, and initially you start by taking some parameter, say randomly some parameter. So is it the right parameter? No, this is a bad parameter. Why bad parameter? Because these points are actually these points are actually going to be told as, because they are below the line, they are going to told as negative, and these points are going to be taught as the positive. So that is a bad thing. So we want to change this model. So what would be the better way that we can we change this somewhere? Can we change this something? Okay, all right. So how to change this? So one way, you know that what is this equation? What is this line represent? This line represent W0 plus W1x1 plus W2x2 is equal to 0. You know this thing. If it is positive, since we apply a sigmoid over here, so we want to see the area where it is positive and we want to see the area where it is negative. Okay. We want to make this thing, whatever's inside this thing, to be positive. We want to make positive for what? Positive for what? For these things. And right now it is not positive. Okay. I want to make this thing negative. I want to make this thing negative for the things which are negative, such as these. For them we want to negative. Okay. So for this example, for this training example, if when I going to put into this equation, if it is going to give me positive, I should reduce the weight. If I reduce this weight, what is the possibility? Okay, what I want to say is this, that I have the value of W0 plus W1x1 plus W2x2. Okay, and the item is positive. But my system is telling, my equation is telling it negative. Why negative? Because this value comes out to be negative. My target is to make it positive. So what should I do? I should increase the value of weight W's. I should increase the W's. Okay. I should increase the value of this. When a positive thing, when a positive thing is told as a negative, weight should increase. Are you with me? Can you understand this part? When this thing is negative, for a positive example, then weight should increase. Are you with me? Are you with me? Say yes. When this thing is negative, when this thing is negative for a positive example, then I should increase the weight. Are you with me? Say yes, no, yes, है ना? Because if you are increasing the weight, then it would not be negative. If you are increasing the weight, then it would become positive. Okay, because these weights are positive. When you increase the weight means they are becoming positive. So therefore this value is going to be positive. If you increase the weight, what would happen? This thing would become positive. So it was telling negative, now it would become positive. So therefore you should increase the weight. This is the first line. This is the important line. Okay. Okay. If it is the right classification, then we should not change the weight. ठीक है. If I am taking this item, putting over there, right classification is given to me, why should I change the weight? I would not change the weight. Next thing is this, when W0 plus W1 x1 plus W2 x2 is positive for negative example, if it is positive for negative example, okay, if this value is positive and the example was negative, if I put those things over here and I find out it is coming out to be positive, so this thing should be negative. How can I make it negative? It would negative when the value of W's goes down. So I should reduce the value of W. Can you see this? Are you with me? I should reduce the value of W's if it is positive for the negative examples. Alright, this is what is written over here. Okay, if you understand this, I am done. Weight does not changes when the classification is correct. For the points, if the classification is correct, then you are not going to change the weight. But if the perceptron output -1 when the actual target is +1, then weight should increase. Otherwise, the weight should decrease. How to decrease the weight? This is the one way to decrease. That initially you have the weight, and let me also see this particular formula because so that it becomes clear to you. See this formula. I have given you a formula, and this is the formula. That what is the formula? Perceptron training rule. All right, let me see this formula. What is this formula? The formula is this: that begin with the random weights. Initially you pick any weight. Iteratively apply the perceptron to each training example. One by one, every training example you consider and change the things. Modify the perceptron weights when it misclassifies. When there is a misclassification. What could be the misclassification? That positive thing is told as negative. Negative things is told as positive. There are two kind of misclassification possible. When positive thing is told as negative, so why negative? Because this W0 was negative. So you want to increase the thing. You want to increase the thing so that the negative becomes positive. If negative is positive, so you want to decrease the weight so that it becomes negative and therefore my classification correct. So you want to decrease the weight. So see this formula, W0, Wi is equal to Wi plus eta times eta is a small constant, target minus output into xi. And here you need to only consider about this term. What is target minus I? What is the target? I see the target is, it should be positive, na? The +1 is the target. But the output is a negative, means -1 is the output. So if you put target minus output, it becomes 2. Okay? If target minus output becomes 2, and you multiply with the eta is a constant, that is a small constant I told you. So it means that this particular formula becomes this kind of thing. Wi plus is equal to Wi plus a constant eta dash, that is a 2 multiplied by this, multiplied by xi, because I have solved this particular. What is xi? Xi is the value of whatever x you have. So this is how you change the things, and you know that if you are adding something, then the value is going to increase. Understood? This value is going to increase. Similarly, into the second case, when it is negative is told to be positive, so you want to reduce the things. So if negative is told to be positive, then you let us again put into the formula Wi is equal to Wi plus eta time. What is the target? Negative. What is given? Minus of plus 1 is given. Target was minus 1, target was minus 1, target was minus 1, and what is the output? Output is positive. So you put it into xi. This formula becomes Wi plus eta dash xi minus, sorry, because this minus becomes minus 2, it comes out to be a different formula. So you see that the things is decreasing. So therefore this is the right formula to train. Can you see this? So this is how you train. This is what the formula is. This is the way you are going to train. So hope this is very clear to all of you. Okay, perceptron training delta rule. Okay, so we have seen that this is the rule. There is another way to train it. Okay, so sometimes training examples are not really linearly separable. When they are not linearly separable, then the delta training rule converges towards the best fit approximation of the target concept. Here we have just seen that the target and output are actually the 0 and 1 only. So we are going to change the thing. Sometimes it may be possible that the items are not linearly separable. Then we want to find out the best fit line, and to go for that we can use the gradient descent. But to go for the gradient descent we need a continuous value. So how can we find out the continuous value? The another way is that you don't apply the thresholding on the thing. What do I mean by that? That I told you that the neuron is that when you have a neuron and a lot of input is given to you, so what you do, you find out the summation over here, then you apply a sigmoid function over that to get the output, and here you apply a thresholding. If it is greater than, if it is positive, then you say that it is class 1, otherwise it is class -1. Okay. So, but my point is that here you don't apply. If you don't apply this thresholding, then you would be getting a continuous value, and that continuous value you can use as a for the purpose of gradient, because otherwise for the 1 and -1, if two values are there, finding out the gradient is not possible. So here I am telling that if your data items are actually intermixed, if your data items are not linearly separable, then you should utilize this kind of strategy. It tells that the endpoint should not be thresholded. So how to go ahead with this? Consider the unthresholded perceptron, where output is given only the W transport X, and then training error is defined as, how to define that, how bad I am, is again the same thing, that you see that what is the target minus output, and you take the square, because now you are getting the values. Okay, so you square this and you find out that this is the training error that is given to you. Now you can use the gradient to find out for every, with respect to the every W, you can find out what is the gradient with of this particular formula with respect to the W0. So you see that the delta E upon delta W0, delta upon W1, Wn, you find out this. And then the training rule is going to be weights updated into this way: Wi is equal to Wi minus eta time We upon delta W. It can be seen that delta E upon delta W is equal to summation of for all the data item. You see that what is the target and what is the output, and you multiply this with the xid. So how can you see this xid? You can differentiate this part. That is not difficult. Okay, you know that target minus. Sir, please explain the slide. Not clear with an example. This slide is not clear. This slide is not clear. Okay. All right. Let me tell you. Yes, not clear. All right. That's very easy. Okay. That's pretty easy. No issues at all. You would be telling by You would be faster than me. So what I am telling is this. The first thing is this, that output you are going to take is, you are not going to apply anything. This is the output that you are going to take. Is it easy? This is not difficult, because weight is given to you. Various weight is given to na W. Vector means, what is the vector? Means values are given to you. W's are given to you. W's are given to you means W0, W1, W2 dot 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 Wn is given to you. All these W's are given to you. And x's are also, x is equal to x0, x1, x2 dot dot xn is given to you. So what is, how you find out? You find out first summation na, of x0, w0, xi, wi. You find out the summation. This is, you know that you find out the summation. Say yes that you know this. You know this? Yes. All right. So if you are going to use directly this thing as an output, you are not applying any sigmoid over there. Then, after however you can apply sigmoid. Let's assume that you are only going to take these values as output. So output is this. For every data item, how many? For every data item, you can find out this output D. Output D means data item has the n values, and you know the what is the W, and you multiply with this and get the what is the value. Then what is the target? Target would be 0 and 1. You know the target is 0 and 1. So target is also given. So you don't know this. Let me tell you that. Let's assume that the database is this. In database is x1 and x2 is given to you, and y is also given to you. And y this time I am going to say that it is target. Target. Okay. So I am going to say that 3, 4 target is 1, 1, 2 target is 0, 2, 4 target is 1, kind of this. Okay, this kind of table is given to you. So given these values, if let's assume that W0, W1 and W2 is given to you. So for this particular line, you find out W0 plus 3W1 plus 4W2. This is what the OD is, this particular thing is. And what is TD? TD is this. Okay. So I think you can apply the sigmoid so that the value becomes into the range of 0 and 1. You can apply the sigmoid. That is understood over here. Because it's a neuron, some function also need to be applied. So you apply this thing, you get this thing. So there would be some, because this thing is not going to be 1. This thing would be something less, some maybe greater than 0.5. So you want to find out the parameter so that it becomes 1. Okay, this value should comes out to be 1, and this value comes out to be other. For these things, the value comes out to be 0. All right. So you can, for all the data item, you can find out this summation. So do you understand this part, that for all the, for this complete table you can find out what is the EW? Can you find out this? You understand this? Say yes. That is fine. Nobody is writing yes. Can you find out this? Should I explain more? Yes, I got a lot of yes. Okay. So you can find out, but if the training data is given to you, for every data item you find out what is this thing. For some, initially you start with any W's and you find out what is this value, what is the target value, find out the subsection, find out this E. This E you want to be minimized. You want to minimize this value. So what you want to, how can you minimize? Again, somebody is asking why half is there. So it is not important, because error, if it is a error function defined, it is for the mathematical convenience only. Later point out you can see that when I am going to take the derivative, because we want to find out what should be the next value of W. Okay, so if you want to find out the next value, Wi is equal to Wi plus this formula, some eta time del E upon del Wi. Why minus? Because if the slope is into this direction, you want to go reverse, because you want to minimize the weights. Okay, you want to minimize the weight. So you can minimize this value. Therefore, you want to minimize the error. Okay, this if at this place you get 1, if this place you get 0, then this value is going to be minimum. So your target is to minimize this value. All right. So you want to see that what is the derivative. And this derivative you would find out using this thing. So can you find out the derivative of this thing? Okay, let me tell you what is the derivative of this thing. So you see that what is the derivative of this thing? Differentiate del E W upon del, say wi, with respect to you differentiate, what would happen? Del upon del wi, it is a differentiation. Half is the constant, it will come out. Okay. Then this is a summation term, summation of term, therefore this would go inside. So what you get half of summation of d belonging to d upon dwi td minus od square, and this differentiation, you know that this differentiation would be 2 multiplied by td minus od into d upon dwi td minus od. Okay, differentiation of this term. So this term is here, this term is here, and then what is the differentiation of the remaining term? Remaining term is this, that d upon dx upon this thing, yani d upon dwi of td minus od. So you know td is independent of wj, it becomes 0. The only differentiation of this thing remains, and this is the multiplication of xi. This is the formula. Okay, therefore, and what is the formula? You can expand this formula, and this is w0 x0 w1 x1 dot dot wi xi plus dot dot dot. If you want to differentiate this thing with respect to wi, so these things, all these things become constant, all these things becomes constant, only this is not the constant, and here only single term is wi is there, therefore this is remained. So this output is xi, so therefore this is the xi term is over here. Okay, xid terms is here. Why I have put d? So because it is related to this data item, therefore I had also put the d, extra d over here. For this data item, x item is there. So you see that this is a differentiation. Okay, so this is how the differentiation comes. All right. So this comes from the intermediate mathematics, that you find out that what is the derivative. All right, this is the derivative that you come up. Alright, if you use this way to modify, means you find out this derivative and then you use this kind of equation to find out, to change the weights, then definitely even if your things are not linearly separable, you would be able to find out that separator that actually separates the thing into the optimal way. This is a delta pertaining rule that is used when items are not separated. Okay, now this is the equation that we have seen, that you can apply the gradient descent center kind of operation, the same thing we have discussed earlier. So multi-layer networks, but we have only talked about that if you have single neuron, how to go ahead, but if you have multiple neurons, then how you can go ahead. Okay, so please note down that we have neuron, not the perceptron, and therefore whatever the output is, output of x is a sigmoid, and then you apply the wx thing over here, where sigmoid of y is equal to 1 upon 1 plus e to the power minus y, you know this, and then the algorithm that we use is called the back propagation. The algorithm that we use is called the back propagation. Okay, so we want to see the back propagation algorithm now. Okay, the back propagation algorithm tells that now can you identify this equation? No, let me go back. This equation you identify for all the data item, how to find out the error. Let me go and tell this thing, because this is very important point to be told. Let me tell you one thing that is very important, and some other square errors. All right, some other square errors. I want to tell you this thing. Okay, I told you that x1 and x2 are my inputs. X1 and x2 are my inputs, and target is my target 1 is for the target is my value that I should get. If I say 3 4 1, target is 1. 4 2 0, target is 0. 3 1 2, 2 cannot be there. 3 1 0, target is 0. Okay. 2 1 1, so you got in this way. Alright, this is the training data that is given to me. I cannot do anything with this. My task is to come up with a function that give me the OD, output 1, output 2, output 3, output 4, and this is the target 1, target 2, target 3, target 4. What should happen? That the difference between target and output, target 1 and output 1 should be 0. Target 1 and output 1 should be 0. Target 3 and output 3, target 2 and output 2 should be 0. Target 4 minus output 4 should be 0. Very small. But because I am training my system, I am starting from the random things. They would have some values, and they can be negative also, because this difference could be negative. So to make them positive, I am getting squares of this, and I want to find out the minimum value. Therefore, the overall error is the summation of all these things. So this is overwritten training target value minus whatever my model is predicting, the difference square for each of the data item. Therefore, this summation comes for the data becomes all the data items which are there. I am going to find out this, and half is for the mathematical convenience, as I told you earlier. That therefore this way you find out this expression. But now you understand that if I have a single neuron, and therefore, and this is the model, then this equation would work. But what would happen if I have more than one output neurons? How many output neurons I have? K output neuron. So, okay, all right. I know that what should be output from here, or what is the output expected to be at these places. So I would again add one more things, that is the K belonging to number of outputs. Okay. So let me just see that what is written over into this equation. So you see that one more thing is required. This is what it is. K belongs to outputs. Means if there are more than one output neurons, then for every, because it is possible, na? Multiple neurons could be possible at the output. Okay. So for them I put that for all the outputs I am going to find out this summation. So this is the only change that we have done, and the equation is actually this, that how to, when you create a multiple networks, then how to train this. So this is how, this is the equation is that a data is given and a parameter, that learning parameter eta is given to you, and in means how many things, how many inputs are there, and output, how many outputs are there, and hidden, how many things are there into the hidden unit. So it's a 3-layer looks like network, and now we are going to train the input, output and hidden layers, and create the feed forward network with the n input and output and n hidden layers. Randomly initiate the weight to small values. Initially you start, the algorithm says that initially you start with the small values, and you repeat for each that x, that is means data, and the each target value that is supplied to you, for that is inside the data. You do what you do, output, what is the output, get the output from the network unit, see the what is the output, and try to see that what is the difference, because now you want to find out the difference, and that is that you compute by delta k. For the output things, you see the delta k is equal to OK multiplied by 1 minus OK into tk minus OK for all output units k, and for the hidden units, this is the formula, that delta h is equal to OH 1 minus OH summation of k belongs to output, WKH delta k for all the hidden units, and then whenever you get these values, you multiply with the xji, and then by this you can modify the things, and you get the, you do it multiple number of time until the things converges, and the thing would converge. This is a similar equation that we have seen earlier. So what was in the previous case? Here, since there was no hidden layer, so this line was absent. Only this line was there, and here the value was, and here the value was this t minus o xi. Okay, so this was the thing that was there, and t minus o xi, and then t minus o is only there. Then you put over here and find out the delta, and you update, keep doing things. But if it is a multi-layer thing, then you change the formula a little bit. For the hidden units, there is a different delta. For the output units, there is a different eta is there. Eta is there. Somebody is asking eta is absent. No, eta is there. Whenever we modify the weights, we actually modify with small things, whatever thing is there, we multiply with the eta. That is there. So this is a different formula, very related to the previous formula, but we want to go into the details of the finding out that how come these values came. How come these values came? So how we find out in the earlier case? Earlier case here na, this was the for error formula. Then we have differentiated this to get this thing. Okay, and then this was a similar formula. Although the algorithm is not written over there, you know the algorithm that initially you randomly started, then you modified the weights using this particular formula, and this formula came by the differentiation of this. So in this case also, what is going to happen? We have defined our error function. So now we need to find out the differentiation of this term to say that how these two terms came. Alright, so we are going to see this. So recall the error function is this. We have seen this for a single training example, because one by one we are going to consider training example. So therefore, if the training example is only one, so therefore for every data term goes away, you can put half of k belongs to output this thing. And now we want to find out weight is updated aging by this. You know that this is eta time differentiation of this thing wij. Okay, all right. So let xji be the ith input to the unit j. Unit is j and ith input. How many inputs are there? Multiple inputs could be there. Wji is the height weight associated with the ith input, means where what is the weight, and net represents that because this particular net j means jth unit would be finding out the multiplication of the weights and the x. So you see the what is the multiplication. Okay, right. Output computed by the unit j is the, you know that the net, on the net you apply the sigmoid. Target, what should be the target output on the final layer? For downstream j means it will be the set of units whose immediate output includes the output of the unit j. So we are interested in this quantity to find out. If you find out this, then you can put into this formula and you find out how the weights would change. Then you would change that weight and you would repeat the algorithm multiple number of times. Alright, finding out is difficult, therefore we put this into this form. Delta E upon D is chain rule. Delta E del of ed upon del of net j multiplied by del of net j upon del of wji. And this, you know that this value, this net is just a multiplication of the weights, so therefore it comes out to be xji, and this remains that what is the value of this thing. So therefore here you see the xj term comes, but what is the value of ed given the net j? So we want to find out if, for the two places where the first we would find out this value for the output units, and then we would see what are the value for the hidden unit. For the output units, again you can the same thing is written over there. You see that chain rule you can again apply del ed upon oj into oj upon net j, and then you can see the first part upon oj is equal to this the differentiation, and you know that the differentiation comes out to be target minus oj, because this is the formula and you can find out this. Alright, note that oj is equal to sigmoid of net j, therefore oj upon net j is the derivative of the sigmoid. Let's find out what is the derivative of the sigmoid. Derivative of sigmoid x is the sigmoid x into 1 minus sigmoid x. Okay, this is what the mathematical definition you can find out. So if you use this term and find out what is the derivative, then you see that it is again the derivative of sigmoid of net j. Same formula, same kind of formula comes out. So you put here the sigmoid of net j 1 minus sigmoid of net j, that is output of j 1 minus oj. Alright. So then what is Eg upon net j means this is the final term that we wanted to find out. This was the multiplication of the two term, and you see that this term and the multiplication of this term comes out to be this term. Okay, this is the multiplication of two term. This term we directly solve. For the second term we have done the derivation, find out this, and therefore this is what the output is. So the term this is treated as delta j, that is what you see that here it is into the previous equation, that is this is over written. Okay, delta j, this is the equation written over here. Alright, for the second part, so we have seen that how the differentiation comes. So therefore the wij is equal to this, that we know, and that is straightforward. For the input units we have seen. For the output unit, how to find out? For all the output units we are going to find out the summation. Therefore this is extended to the formulation, and therefore it comes out to be, you can see this derivation, that is straightforward simple derivation, and you therefore come out be delta Wj is equal to eta time something, and you find out this equation comes out to be, and this equation whatever this equation comes actually is written over into this equation. Okay, in this formula, you see that this is written over this formula, so you see the derivation is there, so that it becomes complete. So for you, don't just see and revise these things, that how we can do all these things. Simple mathematics is there, and this is how we find out. Okay, all right. So we have seen that how we can train the network. If we have a network, so there is a mechanism. You can understand that the back propagation provides us a basis by which we can find out the appropriate parameter. At least this much you can tell that you know. Okay, from this class, you at least you can say that we have talked about that there is a mathematical basis by which we can train the weights, and there is a mathematical thing. Yeah, nobody is going to tell you, give you the example that by yourself you can solve, but you can know that how you can solve. So you understand this part, that given a neural network, how to find out the appropriate weight. If you can find out the appropriate weight, then it would be able to solve any of your problem. All right. Then back propagation also adds one or two things. That is, one is adding momentum. What is momentum? Sometimes you see that whatever I has added earlier should also have an impact into this thing. Why we want to do this? We will be seeing very soon. The impact means early, whatever you are modifying into this step, you are using something from the previous step also to modify it. Sometimes learning is arbitrary acyclic network. You can go for the feed forward network to arbitrary depths. The hidden layer is determined. You can different formula. So what is the main reason? This image is not the first time you are seeing. Earlier also you have seen the same thing. What is happening that whenever you want to minimize the thing, the surface is not straight. It is very different. This is the point where the minima exists, but you see that if you are here, you cannot go to this point because a lot of mountains are there. Similarly, if you are here, going to crossing all the mountain, coming to this valley is very difficult. Similarly, if you are here, you go down into here, that is not the global minimum, then you come out of this and then you can come here, again becomes difficult. So this is the biggest problem with this kind of setting, that this back propagation actually takes you into the local minima, and there is no way to come out of that. So that's why we are going to use the momentum sometime, because if you are moving in some particular direction, if you take a jump, then it may be possible that you can come out. So that's why we are using the momentum. Okay, so it is suggested to use momentum, true gradient descent, or the multiple networks. Realize the different means you start by multiple number of time of initialization, and you can do all these things. Any Boolean function we have already talked about, that can be precisely be represented by some network having two layers only. Every bounded continuous function can be approximated with arbitrary small error by the network with a two layers unit. Any function can be approximated to arbitrary accuracy by the network with a three layer of unit. So all these things are statements that tells that that this kind of network is going to be very powerful. It's not a very simple toy model, it's actually actual general model. Okay, we know that this is the biggest problem, that when we given the training data and we somebody is asking what is the momentum. In the previous slide there was this particular term given, that if you want to modify the weights and you are using whatever the modification you have done earlier, you use that value also, some fraction of that, to modify this thing, it is called the momentum. All right, so we have also told you that most of the time this training stuck into the local minima. To come out of that, you can use the back momentum, and sometimes it can help you to come out of that. All right, the biggest problem that we have already seen, that if the given data, if my network is very good on the given data, what would happen for the new things? It is going to give me the problem. Okay, so what you should do? Okay, continuous training until the error becomes 0. is not a good strategy. Wait, decay, or use of the validation set is suggested. It is suggested that you, as you go ahead, you stop before you get the correct results. Okay, and it is also suggested that sometime input or output encoding is you can use. For example, if you what I want to say by this, say you in an image, you have an image, and in the image there could be cat, there could be lion, there could be car, there could be human, So if all these things are possible, then how would you make the network? You would provide the image, and then there would be some first layer, all the things are given, and then second layer, then third layer, then fourth layer, whatever you do, and at the end there would be in the final layer 1, 2, 3, 4. There would be 4 neurons, and 1 neuron for each thing, each category. If it is a lion, and then this would be 1 and all other would be 0. If it is a human, this would be 1 and all other would be 0, because I told cat, lion, car, and human. Okay, so sometime it is better that instead of using 4 things, you use only 2 things. How can I use? You say that since instead of 4 output, you can take the 2 output only. If it is 0, 0, it means that it is cat. It is 0, 1, it means that lion. It is 1, 0, then it is car. It is 1, 1, then it is human. If you go like this, then you need not to have 4 output. You only small 2 number of outputs. You can take the same work. This is called the output encoding. So sometimes it is better if you go for the output encoding, input and output encoding. Then we would also see one concept that is called the recurrent neural network. What is a recurrent neural network? Sometimes the data is such that there is a relationship that this is the first data item, second data item, third item. Most of the time when the data is given, if you change the order, it is not going to affect anyway. But sometimes the data has a locality information also, such as this is the first data item, second data item. To handle those items, so you create the network in this way. What is the network? That whatever input you are going to give, general network is this feed forward network, where the xt is given the input. Xt means at the time t, this is the input 1, 2, 3 input are given at the time t, and then the next layer, and then the output layer. This is the output. Okay, so if you change the network in such ways that you temporarily add one more node, and that is this input you are not providing, because how can you provide this input? It's not with you. In this layer also you have increased one more neuron, and you take this input and put it here, and then you only input the things over here and get the output is here. So what is the what is the thing that what is the advantage that you are going to get? This is called the RNN. Okay, this is called the RNN. What is the advantage? Let me tell you. All right. So earlier, what this is what the structure you have the structure. So what would happen? Your data is like that. What is your data? Your data is this, that at time 0, at time 1, at time 2, at time 3, at time 4, x1 and x2. Let's assume that x1, x2 2 inputs are there. Okay. So initially the input is 0, 0, 1, 0, 1, 2, 1, 3, 4, 1 kind of data is given to you. And now in every case you want to see that some output. Okay, there is some output, whether you are making profit or loss or like that. Okay, in every case you want to find out whether you are making the profit or loss. So okay, so what we should do, let me take it here. All right. So you make the circuit at the time, say time 4, you want to find out whether you are making the profit or loss. So this is what that is your output is. At that time, to make the profit, to understanding of the profit and loss, this is how the things are connected. and you would be, what you would be your input? Your input, let's assume that only two things are there, not three things, because I have written only two things. So let me say that it is only two things. Okay, so you take this thing and this is the network. Okay, all right. So you have given at the time 4 and 1 you have given, and you have got some output. What is the output? Okay, but this output is not dependent that what has been happened earlier. But if you go for this particular kind of circuit, so this circuit has one more node. Okay, this circuit says one more node, and that is also connected with everything else. But this output, input to this is coming from somewhere else. Okay, it is coming from the previous time. Okay, this input is coming from the previous time. So there was one more. Let's assume that there was one more previous time. What you have input? You had input? Previous time you have input this 1 and 3. Okay, this was your input. All right, this was your input previous time. This was the input. All right, to get the classification. So previous time something from here, it is actually feeded over here. All right, and now the net to complete the circuit, this is also connected with all of them. Okay, this is also connected to all of them. Okay, so at the time t, when you wanted to find out what is the output given 4 and 5, okay, the circuit is such that because it is taking input from the previous time input, that was actually when you have fed 1 and 3, then whatever the output at this place was, this is actually feeded over here. So in a sense you can see that only 4 and 1 are not feeded. Something from 1 and 3 had also been fed. Okay, similarly you can extend it further. So let's assume that in the previous time when you had 3 things again, at that time what you have fed? This thing 1 and 2 you have, when you have fed, okay, this. Okay, at that time also this was also being provided. Okay, so to take the decision, this is given. So you can see that is this time whatever output you are going to get, it depends not only 4 and 1 but also on the 1 and 3, and 1 and 3, since the output is coming from here and it is related to this, therefore it is also dependent upon 1 and 2. Similarly you can unfold this up to whatever time you wish, and you can see that this kind of network actually take care that whatever has earlier been fed to it. So this is called the unfolding, that you can understand that whatever was given 1 2 1 3 4 1, everything is taking to be considered when the output is generated over this particular moment. So such a network is called recurrent neural network, or RNN. Okay, this is called RNN. Value of the CT is defined at the value will be at the time t minus 1, because this value is defined at the time t minus 1. By this is incorporate the history of the network. However, the training is difficult. For training of these models is very difficult. Shailesh, have you got the idea? Have you just got this idea that if I create the network in this way, that in this network what I have done the modification, that I have, everybody please be with me, I am repeating once again the important concept, that this is the neural network that we know, that whenever you provide some input it gives you the output. I am changing a little bit, and I am changing a little bit, that I am adding one more nodes over here, and this, what is the purpose of this node, that whatever the outputs was earlier, and at the time, because there is a space, you see that at the time t minus 1, whatever the output given by this is actually feeded over at the time t. What does it mean? It means this formula. If you can visualize this thing, then only you would be able to understand this. Okay. So at the time, let's assume that the time t4, if you want to find out what is the output, at the time t4, if you want to find out what is the output, so how would you get? You would feed 4 and 1 into this network. But since we have modified this network in such a way so that this also needs something coming from the when you have feeded 1 and 3, and therefore this network, however producing the output based on the 4 and 1 only, but logically it is also considering the input when you have provided 1 and 3. That you understand or not? This part is clear? Because of the construction, it is also considering the things from 1 and 3. Is it clear? Alright, if you can understand this, then I am very happy. Then you would be able to appreciate that this is also considering the things when you input this thing. Okay. So, alright, so you see that whenever I am feeding this particular input and try to see what is the output, and then this particular kind of modification that I have done, this particular kind of modification that I have done, this kind of modification that I have, because of this network, whatever the output I am going to get over here considers everything that has been shown to it from the starting. And such kind of network alteration actually gives you a different kind of network structure, and this network structure is called the recurrent neural network structures, RNN. Okay, so students are asking that it is not clear. If it is not clear, once again I want to try for you that you understand one thing, that it is called feedback from the previous iteration, right? Yes, I am getting feedback from the previous iterations. Yes. So some student is telling that he is not able to understand. Please, it's your responsibility to say yes that when you understand this. Otherwise, I would assume you are not getting my points. You understand that this network? Say yes. Do you understand this network? That how to come up with this network? There is some data. You have provided it, and now it is going to give you some output. So given the input, it is going to give the output. Such kind of network, how to train, we have discussed into detail into this class. That how to farm them, then we have found this. Then how they are going to give you the output, you know. Okay, so we know this, how to train them. Sometime it is needed that whatever input I am going to give, this sequence should also be taken into care of, because if I am going to give the things into different sequence, output should be different. If you want to do this, then you have to modify this using everything is same. Okay, everything is same, only one more node is added over here. In this way you modify. Do you understand this? Do you understand this part? No? This modification you understand? Alright. If you understand this part, then I would go into this slide and hope you can tell me that you understand this thing also. That when I was in this slide, when I have input 4 1, so what was the output? It was not only dependent upon the 4 1, but something came from the previous one. At that time I had feeded 1 3, and therefore this output depends upon 4 1 and 1 3. Is it clear? No? Yes? If it is clear, then you can see that this output was also dependent upon 1 2 and everything. So you see that if you want to incorporate the timing things, so you can go ahead into this way. A simple modification in the network would lead you to handle the things which are coming into the sequence. Okay, that was the point that I wanted to make it clear at this particular moment. So this kind of network is called the recurrent neural networks. Okay, so that's all for today. In the next class, we are going to see about the self-organizing maps, boosting and bagging, and then we would be in the next class. We would be seeing the deep learning. Somebody is asking that whether tomorrow is the class. I don't think that do we have the class tomorrow, and hope I don't have the class. It looks like that next week we have 2 classes, but this week, tomorrow there is no class. Hope you understood these things, and thank you very much for joining this session. So in case you have question, we can take it up. I'm going to stop the recording, so otherwise it would become very